And we talked about this stuff last chapter. We got good at distributing, right? Let's very quickly run through this distribution in order to set up what we're going to do today with these special products. I multiply the first terms together, gives me x squared. I multiply these terms together, gives me plus 9x, right? And I can do negative 9 times x is negative 9x. And then negative 9 times negative 9 is negative 81.
It's easy.
Yeah, well, this is chapter 7 stuff. This is review. Now, the trick today, remember, factoring is the opposite of distributing. We did distributing. We went one direction. Factoring is coming the other way. When I clean up that product, what do I get? What does that simplify to? X squared minus 81. So the challenge today is if I hand you something like this, 4x squared minus 9, can you tell me the original factors? What should go there? Here's the rule. This x squared, that is x times x, right? These guys?
I got it.
81, that's 9 squared, right? 9 times 9? So let's use that property to go the other way. Since these are both perfect squares, and I subtracted them, what's the square root of 4x squared?
2x.
2x. So 2x and 2x. Square root of 9? 3. So let's do a plus 3 and let's do a minus 3. We've now factored it. The nice thing about the difference of squares rule is that the only way to factor two perfect squares that are just two numbers subtracted is to do this rule. There's no other way you can factor it. So you don't have, excuse me, you don't have to try to decide, does this fit or not fit for various circumstances. It's always going to be just like that. Now let me throw another thing up here to kind of add on to this. The rule looks generally like this. You'll see a squared minus b squared. Factors is a minus b, a plus b. A and b just mean anything squared minus any other thing squared.
Oh, so you're just doing those at example.
Yeah, that's the rule that we usually put in the textbook and say, guys, memorize this rule. Because a and b can be any quantity. You usually will see it first off with things like 4x squared minus 9 or other obvious perfect squares, but it can vary a bit. I'll do one more on this page before we go to the next. Show you another one like that. Let's switch to green.
Does it matter which spot you put the threes in?
No, well,
Those are negatives?
yeah, you could do, theoretically, you could do 2x minus 3 and 2x plus 3. It'll still work. Yeah. Guys? Okay. Guys, can we quiet down, please? The rule is this. If it's a number squared minus another number squared, then this is what the factors look like. I take the square root, because 2x squared is 4x squared.
Where'd you get the 4 from?
The 4 is right there in the problem.
Yeah, where'd you get that from?
It was in the problem. The problem said factor.
I thought the problem started up there.
No, that's a different problem.
Oh, alright.
Okay, good. Guys, let me put up a whole fresh problem to look at so we can kind of keep this rolling. So let's say we've got, let's do x to the 4th minus 16. Can I get x squared by multiplying two things, or x to the 4th by multiplying two things together?
X squared.
X squared times x squared will give me x to the 4th. Can I get 16 by multiplying two things together? 4. So that means the factors are going to be x squared minus 4 and x squared plus 4.
Is that all we're doing today?
That's one of the new rules, yeah. Now, I do want to caution you guys. There is no way to factor this. If I have, say, x squared plus 25, it's not the odd number
No, it's because there's no negative.
because there's no negative. Since it's plus, it doesn't work. The rule only works when we're doing the difference of perfect squares. I obliterated this 1 and the 16. Let me put that back. There we go. All right. The advantage, whenever you see two things subtracted, check to see if they're perfect squares to see if you can apply this rule. If they're added, don't even try. Addition doesn't work for this property. We'll do one last one to round this out then. No, there's other rules today. I just want to we're doing one rule at a time. So say we do, well, you might see something like this actually. 4x squared minus 36. No, I don't want to do 36. 27. Nope, that's not going to work either. Let's do 4x squared and 49 y squared. There we go.
No factor.
7y plus
Oh, it's factorable.
2x minus 7y plus 7.
Yeah. Take a look. 49, you know, is a perfect square, right?
Yeah.
So 49 was 7 and 7. Y squared is y and y. 4 is 2 and 2. And x is x and x. So this is going to factor as 2x plus 7y and 2x minus 7y.